Howdy folks, welcome back. Today we're going to be looking at section 9.2, adding and subtracting rational expressions. Our goals for today are going to be able to simplify rational expressions by adding and subtracting, as well as simplifying complex fractions. Something to keep in mind here, we want to make sure to add or subtract rational expressions. We want to find the least common denominator. To do that, we're for sure just going to go ahead and try to make the denominators the same thing. Okay, so moving forward here, our first question, we have 7a over 4b plus 4c squared over 10. First step we want to do is we want to think about these denominators. I have 4b and I have 10. So let's first think about the numbers. 4 and 10 can both go into 20. So I'm going to go ahead and multiply this right one by 2 over 2. And I'm going to multiply the left one by 5 over 5. Now, if I multiply this one here, this will give me 20b. And if I multiply this one here, I get 10. I'm sorry, I get 20. One is 20b, the other is 20. We need to also include a b on this one. We essentially have to have the denominators be the same thing in order for us to go ahead and be able to simplify and combine these fractions. So let's multiply straight across. What we do on the denominator, we have to do in the numerator. So I have 5 times 7a. That'll be 35a over 20b. And then over here, I have 4 times 2. That'll be 8bc squared. This right here is going to be our combined rational expression. Big thing I want us to make sure we recognize is that anytime that our denominator is the same, we can put and combine the numerator's stuff together. So since I ended up with 35a over 20b plus 8bc squared over 20b, we can simplify that to be 35a plus 8bc squared all over 20b. Okay, we're going to do something similar for the next one. One thing that I'm always going to recommend us do, though, anytime you see subtraction, change that to be a positive, and then distribute the negative to the numerator of the second piece. It's just going to save you a lot of headache. Okay, so for this one, we've got 2x over 9y, and then we have plus negative 7y over 6z. Now again, we want to think about what do we have to multiply in order for these denominators to be the same thing. I have 9y and I have 6z. I know that 9 and 6 both go into 18. One of these has a z. This doesn't have a z, so it needs it. This one has a y. This one doesn't, so it needs it. 9 times 2 will give me 18. 6 times 3 gives me 18. So I have 2 times 9, which is 18, yz. 6 times 3, which is 18, yz. So my denominators are the same. We want to make sure that we also multiply the numerators by the same thing here. So as we continue on here, let's go ahead and multiply straight across. So our denominator is going to be 18yz, because both of these will be the same thing. 2z times 2x will be 4xz plus, we'll have negative 7y times 3y, which will be negative 21y squared. And that right there is going to be our simplified rational expression. Okay, let's move on to our next couple. These are going to be some of my favorite for this section, mainly because we're going to be doing more factoring. Okay, first step, actually real quick, again, we have a negative, or we have a minus. Let's change that to be a plus and distribute that negative to everything up top. From here, we want to identify the factored form of our denominators. So this left piece, we end up with 2x plus 1 still in the top. Our denominator becomes x plus 5 by x minus 3 when we factor. Then we'll have plus negative 7, we'll factor out of 5, 5 by x minus 3. Now the thing we're looking for is we're looking for what one of these pieces has that the other doesn't. We have an x plus 5 in the denominator. We have an x minus 3 in the denominator. We have a 5 and an x minus 3. So notice how we both have an x minus 3, but we're missing the other pieces. So what we're going to do is we're going to multiply by the missing piece. Our fraction on the left here, a rational expression on the left, we have an x plus 5 and x minus 3. We don't have a 5, so we need to multiply that by 5 over 5 so that the denominators can be the same. Over on our right rational expression, we have a 5 and an x minus 3. We do not have an x plus 5, so we're going to want to multiply that by both our numerator and our denominator. And let's go ahead and simplify. Now we know that everything in the denominator will be 5, x plus 5, x minus 3. It's going to be the same for both our left and our right, so the denominator can stay like that. And let's go ahead and distribute what we have here. 5 times 2x will be 10x. 5 times 1 will be 5. Negative 7 times x will be negative 7x. And negative 7 times 5 will be negative 35. Let's go ahead and combine the stuff on our numerator. We have 10x and negative 7x. That'll be 3x. We have 5 and negative 35. That'll be negative 30. And on our bottom, we still have 5 by x plus 5 by x minus 3. So 5 there. Okay, so similar for our next one. We want to go ahead and factor everything in the denominator and then identify what the other pieces are missing. So our left one, we have 3x. I'm going to go ahead and factor out a 4. 4 times x squared plus 1. I changed my subtraction to be positive and I distributed my negative. So I have negative 2x squared on the top. And then we have a difference of squares here. X to the fourth, the square root is x squared, and then 1, the square root is just 1, and we have a difference because we have subtraction. So this will be x squared plus 1 times x squared minus 1. We want to identify what each piece is missing in the denominator. We have a 4, an x plus 1. We have an x plus 1, and an x squared minus 1. Our left rational expression is missing this x squared minus 1, so let's go ahead and multiply both our top and our bottom by x squared minus 1. And our right rational expression, we have a x squared plus 1, x squared minus 1. We're just missing the 4, so let's multiply by 4 over 4. Again, we're just multiplying to try to get these denominators to be exactly the same. Our denominator here will be 4 times x squared plus 1 times x squared minus 1. Let's distribute on the numerator. X squared times 3x will be 3x cubed. Negative 1 times 3x will be negative 3x. And then negative 2x squared times 4 will be negative 8x squared. Our numerator doesn't have any like terms, so let's just leave it just like that. And that will be our simplified rational expression. Let's go and continue on here. So we've got a little bit of a word problem here. Still essentially asking us to do the same thing. So the rate at which some oil wells pump oil in thousands of barrels, given X years of pumping, can be represented by this expression. We want to simplify it so that it is one expression as opposed to two being added together. So we have 20 over X plus 200X over 3x squared plus 20. We want to turn these two expressions being added together into one singular one. To do that, we want to get those denominators to be the same thing. So I notice I have an x, and again, like I said in our previous video, anytime you have addition or subtraction, put parentheses around it. It's going to make your life a lot easier. So we've got a 3x squared plus 20 and an x. I notice that this one is missing an x by itself being multiplied, and I notice that this one is missing the 3x squared plus 20. So I'm going to multiply both our numerator and our denominator respectively by those. And let's go ahead and distribute. So in our denominator, we have x by 3x squared plus 20. And here, 3x squared times 20 will be 60x squared. 20 times 20 is 400. And then we have 200x times x. That'll be 200x squared. I've got some like terms in our numerator, so let's go ahead and combine those. I've got 260x squared plus 400 all over x times 3x squared plus 20. That's going to be one singular rational expression to represent the rate at which the oil wells pump in thousands of barrels. Okay, we've got one more page left of these notes. Let's go ahead and jump to the next one. Okay, so we're going to go ahead and simplify complex fractions using different least common denominators. Now, big thing here, do this one piece at a time. Anytime that you are asked to do a fraction within a fraction, because this whole thing right here is essentially saying, okay, we've got x over y plus 1 divided by y over x minus 1 over y. Now, I don't want you to think about it this way because this is the ugly way to think about it. What I do want you to do, though, is I want us to go ahead and think about each individual part when we're solving this. I want you to start with the left one, and we want to turn this into one expression. Notice how we have an x over y plus 1. This is two expressions. Let's make this into one expression. So in order to do that, we need to have the same denominators. Notice how this has a y, this had really nothing, which is just a 1, so we need to multiply this by y over y. Our left expression here now is x plus y over y, and I want you to think about that as being the same thing that we have up there. Now, we have to also do the same thing for our right expression. Again, I've got a subtraction. Let's go ahead and change that to be plus a negative. So I've got y over x plus negative 1 over y. I need to get these to be the same denominator. So I'm going to multiply this one by y over y, because this has an x but not a y, and multiply this by x over x, because we're missing the x there. So that our secondary expression here will become y squared minus x over x times y. And this should look very similar to what we did in our last set of notes, where anytime we are dividing rational expressions, let's go ahead and multiply by the reciprocal. So I've got x plus y over y times x times y over y squared minus x. We cannot factor out any x plus y or the y squared minus x. The only thing that we're going to be able to cancel out from the top and the bottom is that y right there, leaving us with x plus y times x over y squared minus x. Okay, let's go and do the same thing for our next one. So again, let's focus on the left expressions first. We've got x over xy. Let's go and change it to be plus negative 2, and that's just over 1. We need these to have a common denominator. So let's multiply this one by xy. So that our left expression will now be x minus 2xy over xy. Now let's go ahead and focus on our right one. Again, let's change that minus to be a negative. So I'll have 2xy. This is essentially over 1 plus negative 3 over y. I'm going to go ahead and multiply this 2xy by y over y, so the denominators are now the same thing. So we'll have divided by 2xy squared minus 3 all over y. Now that we've got the two together, let's go ahead and work some magic here. We've got x minus 2xy over xy times y over 2xy squared minus 3. We can factor out a y, and there's actually one more thing that we're going to be able to factor. Let's go ahead and look at this top piece. Now, this top piece, we have x minus 2xy. There's actually a GCF of an x, so let's factor out an x to be 1 minus 2y. So now we're going to be able to cancel out the x's as well as the y's, leaving us with a simplified rational expression of 1 minus 2y over 2xy squared minus 3. Perfect. Let's go ahead and continue moving on here. Let's look at the last two examples for this set of notes, and we're going to do essentially the same thing. Okay, we want to simplify the left, then the right, turn them into one singular expression, and then we're going to divide them individually. So I've got x over y plus 2 over x. We're going to need to go ahead and multiply both of these. I'm going to multiply this one by y over y. I'm going to multiply this one by x over x. X times y, x times y. We're going to be left with the same denominator. So I'm going to have xy as my denominator. X times x leaves me with x squared, and 2 times y leaves me with 2y. So this right here will be my left expression. Let's go ahead and do our right one. I've got x over 2 minus, let's go ahead and change that to be plus a negative over x. Let's go ahead and multiply this one by x over x, and multiply this one by 2 over 2, so that we are left with a denominator of 2x, and then x times x will be x squared, and then we'll have minus 2y. Okay, from here, let's go ahead and, since we're dividing fractions, let's multiply by the reciprocal. So I have x squared plus 2y over xy multiplied by 2x over x squared minus 2y. There's only one thing we're going to be able to get rid of here, and that is going to be those x's right there and right there. So our simplified form will be 2x squared plus 2y divided by y x squared minus 2y. You can go ahead and distribute that if you want. I personally prefer it in its factored form like this. Okay, last example. If you want to give this one a go on your own, go ahead and pause the video. If not, let's go ahead and work our way through it. So our left one, we've got 1 plus b squared over a. It's essentially 1 over 1. So let's go ahead and multiply this by a over a so that we have a common denominator of a. So we now have a plus b squared over a. That'll be our left one. We are dividing. Now let's go ahead and do our right one. I've got a over 2 plus negative a over b. We're going to need to multiply both of these. Let's go ahead and multiply this one by b over b, and this one by 2 over 2. Let's go ahead and simplify these here, multiply them out. I'll have ab minus 2a all over 2b. And let's go ahead and simplify this. Let's go ahead and use blue. That looks great. So we have a plus b squared over a. We're going to multiply by the reciprocal. So it'll be 2b over ab minus 2a. You can, if you want, to factor out an a of this ab minus 2a, so this becomes a squared. But realistically, it's not going to change the outcome. Nothing's going to be able to be factored. So I'm actually just going to leave it just like that. It looks good to me. And that's all I have for today, folks. Thank you so much. I will hope to see you soon.